We're excited to have you here. Want to welcome you to Flatiron School's AI-volution, unleashing the power of AI in software engineering. My name is Corey Mickelson, and I am the event coordinator here with Flatiron School. A big part of my job is hosting free webinars like today's event to give you all the opportunity to meet some of our team and get a better feel for the Flatiron School experience. A quick reminder, we're using the chat as our main source of communication, so make sure that little blue button is changed from host and panelist to everyone so we can all chat together. Without further ado, I'd like to introduce our guest for today. We have Michael representing our admissions team.
Hi, everyone. Welcome.
And we have Alvi representing our software engineering team. Go ahead and take it away.
Hi, everyone. Let's see, let me start sharing and then we'll get started. Right, I'm also going to open up the chat. So if you have any questions at all, feel free to ask in there. Or I guess there's a Q&A feature as well, which you can use. And then if I miss any questions, Corey will let me know, and then I'll try to answer all of them. And I do see a lot of people in here, so I'm excited to talk about AI. So before I get into the AI for software engineering stuff, just a quick note on what exactly I'm going to be talking about. So the primary focus for today is to give you a better idea of how artificial intelligence methods are used in software engineering specifically, right? And we'll see two main areas where they're used. I'm not going to talk too much about prompt engineering, but I do have resources at the end which will help you do prompt engineering better if that's what you're interested in. So first of all, I'd like to get started with just talking about what AI is, because it's become a pretty loaded term. So I just want to make sure we understand the differences between some of the terms you're likely to see when you are learning AI tools. All right. So just as a very broad category, right? Like very broadly speaking, AI means it is the science of engineering of making intelligent machines, right? Meaning we're trying to get the computer to do things that are considered or historically considered difficult for computers to do, right? For example, computers are fairly good at doing complex computations, right? If you give it a math problem, it can do it in seconds. However, things we as humans can do in seconds is hard for the computer. For example, I can look at a cat and say that it's a cat, right? Even if it's dark outside, if I see like a rough shadow of a cat, I can see with a fair amount of certainty that it is a cat, right? However, getting a computer to understand that it is looking at a cat is very, very, very hard and requires immense amounts of computation power, right? So we'll talk about like the development AI in a bit, but basically things that are easy for us as humans have been historically very hard for computers. Well, it still is. We just have much more computation power these days to tackle those problems. The reason I bring up the history of AI is because it's important to understand what is causing this explosive growth in AI today, right? Because as you can see in the timeline here, people have been researching AI for decades. Why is it that now all of a sudden everyone's talking about it, right? One of the main reasons is, although people had ideas of AI in the past, they just didn't have the computing power or the data available for making large-scale AI models, right? So sometimes what happens is in the research world, people come up with ideas and then the technology isn't quite there yet to implement them, right? For example, the transistor idea was invented very early on, right? Like in the 1920s, I think. But it was not until like the 1940s that we had a working transistor. So sometimes it takes years for technology to catch up to research, right? So at this moment in time, right, we do have very high computation power. We have access to immense amounts of data, or And on top of having immense access to data, we also have the technology to store immense amounts of data, right? So in addition to all of that, research hasn't stopped, right? Scientists have been researching models since forever, right? So when you combine all of these things, the access to computation power, the access to large scale of data, the ability to store and process that large amount of data, you get a perfect mixture for AI models to take root, right? Um, which is why you may have seen that with the release of ChatGPT, people have started using AI on the consumer side because businesses have been using AI models for quite a long time. But ChatGPT opened it up. Well, not just ChatGPT, like you have other things like Bing Chat, and then you have like creation tools, right? Like AI have been integrated into consumer software that historically didn't have any consumer facing AI features. For example, Photoshop allows you to use AI to generate certain artwork or edit pictures these days. So that's where we're at right now. The computation power has finally caught up. AI is being released to consumers, so we're seeing an explosion in AI technologies, right? So I've been using the term AI quite a lot. But when you're studying AI or trying to learn how to incorporate AI into your programs, you'll see terms like machine learning and deep learning as well, right? So what's the difference between these and why are they within circles, right? So AI is like I said before, it's a broader idea of getting computers to do human things, right? Machine learning is a subset, and it's more practice focused, meaning like it's a combination of mathematical models that allow you to make models learn, right? So machine learning is the application that allows computers to show artificial intelligence, right? So artificial intelligence is the broader term. In addition to machine learning, you might see other terms like NLP, which is natural language processing, meaning the ability for computers to understand human language. You might also see terms like computer vision, right? So those would be like separate from these machine learning. And then you have deep learning, which is a subset of machine learning. So a lot of the more advanced tooling you'll be using will use some form of deep learning model for actual applications, right? So you can use software libraries to feed in data to your model and then get some output back that you can use, right? Before I move on, does anyone have any clarifications on what AI means? All right, so I will talk about how specifically AI is being used in software engineering, right? Since someone has a question, if you have a question, feel free to ask in the chat. I'll try to answer it. So software engineers, like I said before, businesses have been using AI models for quite a while. So they weren't using interfaces like ChatGPT in their work. So how were they using these models, right? Now, before I talk about it, right, let me show you some data like that developers are actually using it, right? So this is from the latest survey from Stack Overflow. So it's a 2023 survey. And 70% of software developers are already using or planning to use AI tools, right? And then 77% of developers have a good experience with it. So basically, AI is here to stay, right? And I have links to all of these surveys and data you can look at yourself. But basically, if you're not familiar, Stack Overflow is one of the most frequently visited websites by software engineers. So their survey is usually pretty good. And then I also have a survey by GitHub linked at the end if you want to look at more data on how people are using them, right? So here are the two main areas where software-focused companies are using it, right? So you have two main areas. The one is product features, and the second is development workflow, right? So what do I mean by product features? So if you're using any type of software, that software solves some problem for you, right? For example, if you're using, let's say Airbnb, the problem they're solving is getting you accommodation to a place you're visiting, right? So anything that they can do to improve that is a product feature of that thing. Similarly, if you're using Netflix, the feature, their like core business is providing you with entertainment, right? Or another way to put it is they want you to engage more with their platform. So it's in their best interest to get you or like show you things that they think you'll like, right? So you have discovery features in Netflix, you can search stuff and so on. So one of the ways Netflix does search improvement is by using AI models, right? Now, when I use the word AI model, what I basically mean is, maybe I'll show you a diagram that will make it a bit clearer. So this is like a high-level overview of a diagram of a real-time system, right? This is a diagram from Netflix's search model. You don't have to understand any of it. Just focus on what I'm about to explain. So notice this thing here, online model, right? This is the thing that's using the AI algorithms inside and then getting input from the user's browsing sessions and then giving some output for Netflix to use, right? So when I use the term model, you can think of it like a box, right? You can think of the model, this is the AI model as a box where you give it some input and it returns some output. So if you were to think of ChatGPT, the input you provide is a text or a query, and the output you get back is also text, but basically it tries to answer the query that you sent it, right? In the case of Netflix, right, the user searches things, they watch some things, and then they have favorite genres, like shows, and so on. So what they're trying to do is use a model to figure out what you like and potentially show you or point you towards shows that you're more likely to view, right? So that's where they're using the AI model. The second thing to note here is that in addition to the model, right? In addition to this AI model, they have lots of things going on here, right? So it's not just enough to develop an AI model. You need software engineers to deploy them so that they can actually be used and then get some business impact out of them, right? That's where software engineers come in. So I'll talk more about like different roles within the AI landscape, but basically it's not just enough to have an AI model, right? And then there are some other models as well. There's lots of models companies build or use existing models and then build on top of it. So you have models for fraud detection. So one application you may have seen is maybe Gmail filters. So sometimes you get emails and then they're directly put into the spam, right? So you can use AI models to figure out if an email you get is spam or not, right? So that's another product features, and another feature that you can augment with AI, right? The second area where they use is for development workflow. So whenever they're writing code, they're setting up tools, building infrastructure, and so on. They use code completion tools such as GitHub Copilot to help or assist them with the coding, right? Now, when I say a system, it's generally the boilerplate code that is usually the easiest to work with, right? When you have complex problems, the AI usually doesn't help. But as software engineers, you have to write a lot of code. So even if it saves you like 20% time, that's a lot, right? So generally, you'll see software engineers use coding tools like GitHub Copilot, Tab9, and so on to help with their workflow. In addition to those tools that directly help you write code, you can integrate AI models within larger systems. So once you have a giant website, such at the scale of, let's say, Netflix or Facebook, they have hundreds of millions of users, right? And you need some way to monitor if the system is working or not, right? And that's where you can use some automation as well, augmented with AI, right? So in addition to all of this, there are some ethical considerations that come into play. And the reason is large-scale AI models work by using a lot of data, right? And the data comes from lots of different sources. So for example, if you've heard of Midjourney, it's an AI where you put in some prompt and then it generates some artwork for you, right? It used the artwork of several other artists to learn how to draw and then create the product, right? So it brings some interesting questions around who actually owns the things that the AI creates, right? Similarly, AI models learn from large scale data, right? And biases might be introduced within that data, okay? Um, so those come into play as well. So the output it generates might use the biases that the input data had. So with any AI model, the quality of the data is really important. If you feed it bad data, you'll get bad output. So if you feed it biased data, you'll get biased output, right? So these are the general AI ethical considerations you will hear about. And these are getting increasingly more important because companies are trying to grapple with how the legalese would work when they use AI models, especially consumer-facing ones, right? So this is another key area where you can focus if you're interested in AI. So before I go on to just talk about how to learn artificial intelligence, let me just look at the chat real quick if there's any questions at all. Okay. Awesome. So learning AI. So I've shown you this diagram before, and there's a lot going on, right? But the thing is, as a software engineer, you're not expected to be able to do all of this by yourself, right? Because this isn't even a full system. This is a part of a larger system, right? This is just the part of the in-session search recommendation system, meaning whenever you're using Netflix, you go to the search bar, you start typing something, you get some recommendations back. This model helps the recommendations be better for you, right? So when you're learning about AI or like trying to use any sort of machine learning models in software engineering, there's some general skills that you'll have to know, right? So one of the primary things you'll have to know is how to program. So programming is a pretty big part of using these models, right? Now, I generally get questions around what language to learn for AI. So Python-based libraries are fairly popular in the ML world. But when you're working with large-scale systems, chances are you'll end up working with various languages, right? But Python is a pretty good language to start with if you haven't started with other languages. If you want to use AI-based tools, Python generally has the best support. So that's a good place to start, right? And then in addition to programming, right, you also have to understand data, right? Specifically, you have to understand how to model data, right? And how to process data. Because as I said, machine learning depends on large scale data and processing them to get useful output from them, right? So you have to understand how to structure data, how to process data, how to make sure when new data comes in, the system still functions, right? So these are the primary things you have to learn. In addition to all of this, you have to learn um, a little bit of, well, not little bit, just to start, um, um, some ML fundamentals, right? So I'll talk more about how much you have to learn depending on what you're focusing on. But when I say ML fundamentals, I mean the basics of how these models work, all right? Because if you have a certain problem, you have to decide what sort of model to use for your problems, right? And that's where the ML fundamentals come in. It'll help you understand better what sort of model fits within the solution you are trying, right? So these are the three main things you have to learn. And generally, you have to learn some backend stuff as well. Backend stuff meaning whenever you use any website, right? There's a lot that happens in the background. So for example, when you start a Netflix video, servers in the backside have to figure out what to stream, how to stream it to you, how to stream larger files, and so on. Similarly, if you have lots of users spread across different places, then you have to figure out how to get information to them, right? So there's some backend engineering involved if you're working with ML models, but primarily you have to understand programming, data modeling, and some ML fundamentals. And then towards the end of the session, I'll discuss like how to learn these ML fundamentals, right? So when you are researching software-focused roles, you might come across some of these terms, right? And I've broken them down into two categories: theory-focused and then practice-focused, right? And the requirements, by requirements, I mean the job requirements, are generally very different between theory-focused and practice-focused roles, right? So when you see roles with scientist or researcher in their title, that generally indicates that the role requires at least a master's degree in ML, but generally a PhD, because the entire purpose of their job is to research new models or how to improve existing models and come up with new algorithms or processes, right? So any research focused role generally requires a pretty good academic background. By good academic background, I mean like published research, right? But companies have different, all sorts of roles. So I've seen the term data scientist being used similarly with data analysts or data engineers. So make sure to read job descriptions to figure out exactly what they're looking for. But if there's a researcher in the name, it's generally they're looking for people with published research. So MS grads or PhD grads, right? Then you come to practice focused, and these are basically software engineers with certain specializations, right? So the Netflix system I showed you, it required software engineers who also knew how to work with ML models to implement, right? So basically what they do is they take models that are developed by researchers and then figure out how to integrate them into existing systems, right? So that's what ML engineers do. You might see the term ML infrastructure engineer or operations engineer or just ML ops sometimes. Again, these are still newish titles. So the job descriptions are usually all over the place, right? But generally what they refer to is the idea that you are able to take all of these individual pieces. Right? You have all these different pieces here, client server, some sort of data source, model, and so on. The idea is that ML infrastructure or ops engineers figure out how to connect all these together and make sure the system works continuously. Meaning, when you put something in production or like make it user facing, and as your users use them, you'll get more data, right? And there needs to be processes in place that make sure that the data you're generating, the data you're gathering, can be useful to your business, right? And in order to do that, you have to make sure all of these separate pieces work together seamlessly, right? That's where infrastructure and ops engineers come in. The ML at the beginning basically means that uh, DevOps or infra software engineers who are familiar with ML model integration, right? Because due to the nature of ML models, it requires some special considerations. Basically, ML models require large amounts of computation power, right? So that involves provisioning or using different kinds of resources than usual applications. So that's where the difference is. As for practice focus, they generally don't require advanced degrees like for researcher roles. So if you are studying for software engineering, once you learn maybe like a programming language and some backend engineering, you can start to learn ML and then integrate that within your systems, right? So that's what ML engineers do, right? Any questions or clarifications on these roles?
There are a couple questions in the chat.
Let me look at them.
Oops, sorry, in the Q&A.
Jensen is asking about C#. I personally haven't used C#, but I'm sure it's used on the back end for certain cases. Because I've seen Java being used for pretty large scale systems. But I haven't seen C# focused ML stuff yet. I primarily focus on the ML engineer focused content. So yeah, I've mainly been using Python for the backend and the libraries as well. So I haven't personally seen or used C#. Jeff is asking if do all AI models require vector databases as their knowledge base? In other words, is the key algorithm logic in the data source or in the model propositional logic? Most models I've seen do use vector databases, especially if you're going to do computation vector. It's considerably faster to do processing on vectors than if you were to store them normally. So I can't say if all models use it because I haven't read about all models, so I can make a generalized statement. But like pretty much all the ones I've used do use it. All right, let's see. Would it be possible to see a brief example of using ChatGPT to help find solutions to a software question? So I have some resources at the end that goes into extensive detail about how you can use prompt engineering. So that could answer your questions. But generally for software related problems, like I said, if it's a complex problem, it's generally the ChatGPT isn't very helpful for me because it's hard to give it the entire context of your program, right? especially if you're working on a large code base. So what I end up doing is I usually use it for like boilerplate generation or some questions that I would ask maybe on Stack Overflow. So it's like a starting point to figure out which direction I should be going. But if I'm working on more complex projects or large code bases, I generally don't, well, not that I don't, it's that I can't give it the full context usually, right? All right. So any other questions before I walk you through some of the resources? Because there are a lot of resources. I didn't want to overwhelm you, but I also didn't want to not like point you towards right resources. So I'll try my best to walk you through the resources and what they teach you, so you can decide for yourself what works given your circumstances, right? Because it seems like there are some software engineers in the chat as well, so they could potentially start with the more advanced resources than starting with the basics. Let's see, there's a QA here. Okay. Oh, I think I answered it live. Okay. Oh, there's a good question in the chat. What external topics to software engineering should we learn or study, like math, statistics, automata, regular expressions, and so on? It's hard to say exactly what you'll need, but generally, if you can program in one language, you should be able to pick up the programming needed to understand these models. As for the math itself, depending on whether or not you are doing theory focused or practice focused, it will vary, right? One thing I do want to point out is no matter what sort of ML role you are in, you do have to know some ML basics, and ML basics require you to use some math, all right? And the math you usually use are linear algebra, statistics, and calc, all right? But if you're in an engineering role, you don't have to know them like super deeply in order to like get huge benefits from them, right? You don't even need like degree level math for it. So for example, when I was learning ML, I studied electrical engineering, but and some math, like engineering is a lot of math. But when I started learning ML, I had to relearn some of the math for it, right? And generally what happens is whatever course you are going through for ML basics, they will walk you through exactly how the math fits into the model. So even if you don't know, if you haven't studied advanced math before, it won't get in the way, right? So I wouldn't worry about it. And there's some really great resources that I'll share. If you're curious, you can learn some of the basic math if you are feeling a bit rusty. Oh, there's another great question. So generally, is creating AI products expensive, right? What other things should be considered before creating a product or starting a startup? So these days, there are lots of models you can use. So you don't have to train your own models, right? You can take existing models and use them. So maybe it'll take a few dollars to provision some servers and test it out, right? So yeah, the cost isn't that expensive if you're going to be creating your own system. Like modern tools and modern technologies have made it considerably easier. So yeah, you can use existing models. Other things to consider. So whenever you're thinking of creating products, you have to understand the market and defining your niche. That's a larger conversation, but the actual implementation of AI wouldn't be the hardest part, I think, but depending on your experience and your co-founders, I guess. So I will talk about some resources here. So on the first page of the resources, it's just some references that you can use to understand what AI is, the difference between machine learning, and so on. One video that I really recommend is this one. It'll help you understand how neural networks work, right? Like these playlists, these are amazing. It'll help you understand how deep learning, that is the most prominent form of machine learning, works, right? It's really good. So the second page is where all the courses are listed. I know it's a lot of courses, but I'll just walk you through what some of these do, right? Or like what they teach, so you can decide for yourself whether or not it's good for you. So there are a bunch of courses in this on this website, so deeplearning.ai. So they specialize in creating machine learning courses, right? And generally their specializations are very theory focused, all right? There's some coding involved in here, but the primary focus is usually understanding the theory behind machine learning. So it takes a very bottom-up approach to explaining you how all the small pieces work, right? So machine learning specialization is a pretty good place to start if you want to know about the different machine learning algorithms, right? Or approaches. And then someone asked about the math behind machine learning. So this basically gives you a pretty good overview of the core mathematics that I described. So it goes over linear algebra, stats, probability, and calculus. So if you are feeling rusty, you can get started here. And all you need here is high school level math to get started, right? So deeplearning.ai focused more on the theory behind machine learning, right? Then you have elements of AI, right? So elements of AI, it's a little bit of both, right? It's a university level course, so it does teach you some theory, but it also like guides you through using Python, right? So you don't need any math or programming experience to get started with these, right? So if you are just curious to see how to use AI for software engineering, this is a pretty good place to start if you're just starting out, right? So elements of AI, another really good tool. If you are more practice focused, if you are already experienced and want to learn more about how machine learning fits into the larger software development cycle, then these three resources are really good, right? So they're heavily practice focused, right? And if I go to one of these, you'll see that the prerequisite says prior programming experience, right? At least a year. But basically, if you finish a bootcamp, you can get started with it. So if you have done a software engineering bootcamp, that should be enough to get started with these, right? Or if you work in the industry, then you can easily start here. So they have two courses. So Data Talks Club, they have two courses. One is Machine Learning Zoom Camp. The other is ML Ops, right? So the machine learning goes over from the very beginning, like what is machine learning, what sort of what different types of machine learning algorithms are available, how do you use them, different models, and so on, right? They do have a section on deploying, but if you're curious about learning about the ML deployment process in much more detail, then this course is for you, right? So it walks you through how to use an example data set and then deploy it, right? So they talk about orchestration and ML pipelines and model monitoring, and then after you deploy it, you have to monitor it. So they talk about that as well. So this is really good if you care about deploying your models or are interested in that. And then finally, you have practical deep learning. This is where they go over a bunch of different libraries. So you can see here, they talk about NLPs and then CNNs, right? And they recently, I just found out they recently added part 2. So it basically walks you through all the common Python libraries that you can use for practical ML experiences, right? So this is also a really good course, and it's taught by a very, very experienced engineer, right? And then finally, we have learnprompting.org. So you can see here, they have a bunch of guidelines on how to use prompting, right? And then they have a bunch of resources in here as well. So if you're working with ChatGPT and are curious about how to use it more effectively, then this is something that could be helpful for you, right? So just to reiterate, this is probably a good place to start to get a better sense of what AI is and also get some basic programming experience. You don't need any prior experience to get started. If you want to learn the theory in more detail, then deeplearning.ai is possibly the best free courses that you can find. If you are more practice focused, you already have some software engineering experience, you have some math background, you can get started with actual software level work with these three courses, right? You don't have to do all of them. If you're more curious about general ideas around machine learning and models, you can start here, deployment here, and then specifically deep learning. This is a good course, right? Yeah, someone asked if these will be shared. I think Corey will send the slides out along with the recording, so you'll have access to them. Okay, let's see. There are some new questions. Oh yeah, so I think I answered them. Any other questions or clarifications at this point? And one other thing I want to note is because AI has become so big in the past few years, the kinds of roles you see might be more varied than what is listed here, right? These are just general roles that I've seen the most. But again, I may be biased because I work as a software engineer and I'm in software engineering. But there's like lots of different areas of AI specialties as well, right? For example, AI ethics expert could be another area. AI product manager could be another. So there are lots of different roles that are available on top of these. So maybe don't pigeonhole yourself to just these. See what new roles are available and how you can fit them within your current experience and skills, right? But yeah, I think we're almost at time. Thanks, Corey, for giving me the extra time. But thanks everyone for joining and for all the wonderful questions. Hope this has been really helpful.
Thank you. I'll be, just to let everybody know, we will be sending out a copy of the presentation with the recording in the next 3 to 5 business days. So thank you all for joining, and I hope you have a wonderful afternoon or evening, depending where you're zooming in from. Have a great day. Bye, y'all.
Everyone.